Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano script. So it's the scripting language I'm working on to integrate into my text editor as like the config system for it, essentially. I want it to be standalone as well, but then also integratable, essentially, is the plan. So I started on it yesterday, and so far, let's see, we can compile this, right? So just a single thing, write hello world, and it will do that basically. So if we build it, we run it, you can't provide any arguments yet or anything like that, but it compiles it. So this is the assembly for my virtual machine, which it will compile then into the bytecode. So if I run this, my output to Kano.tasm, then oops, Kano.tasm. So this is the assembly. Why is there two? Oh shoot. Yeah, because the file already exists. So I just output it to it. So if I try that again, run that, and then just look at this, and see this is what it generates, and then I can run the assembler on it, and then it generates this bytecode right here. So I can look at that in hex edit, and then here is the strings. You can see they're here. The string that we provided, and then there's also, these are like the instructions and stuff. So it's just a bytecode. It's not human readable or anything like that. But then we can run the runtime on it. And hello world, outputs that. There's no save characters, new line, anything like that. Not yet. So today I want to make it, basically make some improvements, and hopefully make it so that we can have multiple integers, like write, goodbye, that kind of thing. And also I would like to implement this, like exit 15. Not going to do any like expressions yet, like, plus 15 or whatever. Just single integers for now, and then next one. How fleshed out is your VM? Let's see, so we can look at it. So there is, if we look in here, so there's quite a few instructions. Some of them aren't used anymore, but you can do like most things with it. Like there's memory. You can write to the memory. You can also read from the memory. That's like, so we can work with strings and things like that. Right now there's only, like, these are all the data types you can have, so it's not like super extensive in terms of that. But I mean, it's pretty usable. Like you can make things in it, and you can call to C functions to interact with the operating systems. Like you can open files and things like that. Yeah. So I'm gonna be basically building the programming language on top of it, and then once there is something else that I need, I'm gonna implement it in terms of the virtual machine. Okay. Yeah, so right now it's just one big file. But that's okay. Let's see. Yeah, so I'm gonna be updating some things. So the way that that we are parsing it is gonna be a bit different. So I want to change that. I'm gonna take, let's see, take that, and then nodes, and then make a dynamic array of it. Right. Node data. Do that. Then I don't need this anymore. It's not referencing itself. And that's gonna break everything pretty much. But that's okay. Then we're just gonna be appending each node to the array. So yeah, so this is gonna need to be done differently. So we don't need this. We're gonna need recursion for like the expressions and such, but not yet. Like we don't need to do that yet. So let's take a look at this. So yeah, we still need to create a node, and then we want to just append it so this is gonna return the nodes. Yeah, so this will be a root, and this is what we're going to be appending to. So we don't need to do that. Alright, so we want to actually allocate. Okay, yeah, and we'll just, we can call that macro to, which is already a pointer, so I think we're fine. Root and append, append a node. Alright, we don't need to set this, yeah, so I'm gonna do something like that. That's gonna be different. Done different. Yeah. And then return loops, we return the nodes. And then, yeah, we should be able to append as many as we need to that. Then for this, yeah, we can just recursively. Well, hang on, I need to think. So if we're appending each one, how do I want to do that? It's really just be with one. So maybe maybe just want to return a single node. How do I want to do that? I'm trying to think. Yeah, so we can do it like this actually, and then just loop over them. So it's going to take nodes. And sorry, no, then we can return. Okay, and then we can just loop over. So then it makes count. Okay, like that. And then yeah, then we need to set the current node. So node equal node.data up. And then yeah, then we can just generate the code based on that. It's on the node type. Okay, so let's see. I need to actually update this. So this is gonna return that. Alright, that should be good there. Let's try to build it, and yes, we don't have that. So we need to update the print tree isn't actually gonna work anymore. I'm gonna get rid of it, because yeah, not valid anymore. Okay, build that. If node as well. Okay, we can do that then. Save it. Alright. Type node from type node pointer. So this needs to be right here. It needs to be like that. Did you mean to use arrow? Yes. Okay. Alright, so it compiles it. Doesn't output anything though, so that's not good. So, so did we make it here? No. Okay. Make sure it did save because it's on. Okay. So we don't make it in there anymore. So now there is an issue with that. Consume. So right now the file is hard-coded, so we don't have to pass it, but we can look at it. Let's get rid of that stuff. Actually, that might be the issue. Yeah, it probably failed because I had all of those in there. So let's try it now. Okay, invalid pointer. So when did that happen? Alright, so let's step through and see. So it's probably in here, right? Okay, so it didn't like that. Alright, so it doesn't like the DA of 10 to the root. So what if the node is stack allocated? Type equals that's all that I need for that part. Yeah, and then allocate it like that. Is that gonna work? Then it doesn't need to be actually still that. this needs to be that. Well, we can just take one, and then I don't have to change the entire thing. Native type. All right, what's it called? Type native. Okay. Okay. Still get that. This doesn't need to be allocated either. It needs to be like that because it's not very much. It's just a pointer. So if you do that, yeah, that's what the issue was actually. I was trying to reallocate, but it wasn't zero initialized, so it was not null. Yeah, that makes sense actually. Yeah, so now we don't have to check that. Okay, so now it actually outputs that. And I think it should work, right? Goodbye. Let's see. I don't have to do it yet. Yes, so it does. So let's try to get exit two parts now as well. So like exit, the fourth one, right? So we'll it's still gonna be the native calls, that'll be the same, but then we need to actually parse the integer. Yeah, so obviously it doesn't work now. And there's no errors yet. I need to actually output errors, but it does not at the moment. So let's start with the tokens. So we need tt exit, right? So this should probably be like token type native, and then we have all the native types. But I don't know. Not doing it. So right exit. Okay. Then that's all that we need. So if we let's see, where do we do that? Where do we check the type? Yeah, get token type. So then exit clear size, then you can return tt exit. Okay, and I think that's pretty much it. So all of that is fine. Yes, we should be able to parse that now. So if I try to, what is it, print token? What is it? Let's consume print token. What is it? Oh, print token array. Okay. Yeah. Print token array, and that should right. Maybe I say handle. That's fine. So it prints that. Yes, we do get exit. And then we don't get anything after that though, because we don't parse the integer. So let's do that. Forgot. Okay. So exit was easy enough, but then tt integer, right? So we're not gonna do floats or anything, just integer. So string and then we just need to check if it is digit, and then just consume it while it still is. So that's gonna go here. Let's see. New.data is digit. And while is digit, new.data. We're just gonna consume it into basically a string builder. Is what we got here. Dynamic string. Basically, like this. Let's grab that, and we can change out change out this for is bigger. We got data. There we go. And just append to the word. Put in word to none, right? Okay. And we don't need to do this equals tt integer. So for now, that's the only number that we're going to support. It's going to be num not data. Is a number. So okay, so let's see. So we have the dynamic serve, right? We need to initialize the token though. Let's grab this and do that. Alright, so token is there. Create the no. And then we want to actually append the first one, so let's do that. No. Well, actually we could just not chop left and then append it here. Yeah, so that'll work. And we set that, and we create that with that. Let's see, do we want to have the type? We could have a different type, right? So let's look at that. Where's the tokens? Here it is. String view values. So let's do, could we just leave the integer as a value? Hey, Alvez, how you doing? How you doing? What is up? Let's do a union. One was okay, so token value. And we'll create a union. So like that. Union. Token value. So we'll have string view. And then we'll have integer, right? Integer. Okay, then we have all those. So that should be helpful, right? That's gonna break some stuff, but that's okay. So we need to update when we parse a string. We need to set the value dot string, right? So this is for that. This is the string. Value dot string. And this we need to set value dot integer. Dot integer to let's see, a toy. I'm not data. And let's actually do, well, yeah, we'll just use integer for now. Even though in the virtual machine we use in64, so we'll need to update that eventually. But for now we can just do that. Num.data. Okay, we should actually set then the append to num, just that. So we have the null termination, right, in the string. To make sure we don't break anything. And then with the append the token, so that should be good. So we are going to get some errors from changing that. Token value has no member name lens. That's not gonna work. Yeah, so we need to update that. Expansion of that. 56. So when we are trying to print it out, we need to update this. It's here. And yeah, so now this is gonna work unless we do dot string. It's also not gonna work for outputting the integers, but we'll get to that. Tokens. Yeah, so we need to update that as well. 247. Value dot string. So when it's a string, we know it's gonna be a string. So TT exit and TT integer are not handling switch. That is fine. So let's put paste the integer here. Like that. Macs are actually very good. Yeah. Are you using a Mac? You mean Macs? It's like the hardware or Mac OS software? Like, how do you mean exactly? So we're gonna need to parse that right now. We'll get to that. Alright, so it all compiles now. And solution failed unreachable. Yeah, because we get to that. So we need to hardware, macOS is yeah, macOS, like, to me, I don't see any reason to use it over Linux, honestly. Planning to buy a Mac Mini, nice. The ARM-based ones, or like an older one. Alright, so we should be able to do this pretty easily. We can just set the node type to type native still. We want to expect token type integer. I think just int. Try to put int literal. ARM-based by far. Okay. Yeah. So like which one then? Like the newer ARM-based ones, or like one of like the M1? Seem like that. Var int. I think I had that. Want to use it as a workstation? Nice. And what operating system are you gonna be using on it? Can you you can install Linux on them now, right? I'm pretty sure it works, right? M2, 8 GB RAM, 256 GB storage, 500. Okay, you can't still. 256 gigabytes of storage does not sound like very much, and you can't upgrade it internally, right? Can use Asahi, but it's not that great. Okay, I see. I wasn't sure because I haven't looked into that. Upgrade with external, yeah, but that'd be kind of slow, right? Comparatively, but I guess let's see. Var int, that should be good. Need to exit. Yeah, so that should be good then. Let's build that. And we had quite a few issues, so it doesn't like that. Trace it around that. Why? Why does it say that? Should I cast this in to a... I don't remember this one. 512 gigabyte is 700, really? So it's $200 more just for the more storage? Really? Let's look at the art. What are the types that we have? Yes, we do have integer. And I notice these are the same thing. So let's just use var value for that. That's really messed up, honestly. Bro. Okay, so I don't get what it wants here, guys. Let's look at this. Chart start from int. Okay, I can cast that properly, right? Is that so cast it to a var type, right? Var value, right? See if I buy if I told storage. See if you buy if I told storage is 1K. Dang. And you can't upgrade any of it at all, right? Like it's all one thing, right? Var. Whoops. Oops. When declared here. Can't upgrade memory. You can't, none of it can be, the internal stuff can be upgraded, right? At all. Okay. The definition of column. Yeah, so I don't know what the issue is with that. It is down here, though. Okay, this, I just need some of these. Okay, that should fix a lot of the problems. Okay, so tt int undeclared. So what is it? tt what? tt integer. I feel like I should just do tt integer. I think that's not a thing, so have a Mac Studio M2 30GB RAM, and it's all I need. Mac OS is also something I got used to very well. I used to GNOME. Hello, how you doing? What is up, everyone? Hello, hello. Yeah, I could see 30GB of RAM. Probably being enough. The integer undeclared. What? Alright, just did not save properly. Okay, so we're getting there. So it doesn't like this. Oh, you got integer. Can I do that? Yeah, then I can't cast it, but that's okay. Hold on, here it is. What are you working on exactly? I've been curious about making my own language at some point. I can go over what it is, because there's kind of a lot to it, and I will talk about it in a second. Let me just see. Yeah, it looks like that works. So I think that'll work now. So I need to just change this quickly, and then I can go over what is up. Okay, so that works. Alright, so there's kind of a bit to it. Something I've been working on for some time. So I built this virtual machine a couple months ago. And recently I polished it up a bit. Still needs some more work, but it's pretty usable now. So it's a virtual machine similar to the Java virtual machine, that kind of thing. And it has a bytecode, and then also has an assembly which compiles into the bytecode, or assembles into the bytecode. And then I built a text editor, which is what I'm using here. It's not actually Vim. It is my own text editor that I built. Obviously, all of it is still actively being developed, but I need a way to configure the text editor, some language for it. And I thought about using Lua or something like that, but then I decided I'd rather make my own. So using the virtual machine bytecode, I'm building a scripting language, which will compile into the bytecode, and then I'm gonna integrate that into the text editor. Yeah, so that's basically what it is. So it's a bit of stuff, but here is, if I remove that, I can show, so this is what the bytecode looks like, or what the assembly looks like. If I run this like that, so this is the assembly, which I'll put into a file. Yeah, so that did not quite work. Oh shoot, because I am printing stuff. So give me 1 second. Yeah, I need to get rid of that line. Now if I do that. Actually, shoot, I messed that up. Now I mess up the file. Okay, 1 second. Push through. So, no, that's not right. So the language I'm working on looks like this right now. This is just the second day, so it's not very much. You can call it write, which is like a native syscall type thing. And then also exit. So that's what we've got so far. And you can run this, and you can output it into the assembly file, right? And why did that happen? Oh, I removed that. I did. I not rebuild. Alright, not working very well, but give me a second. Okay, that's better. So into this, and then here is the assembly for it. Yeah, so it's like push strs, that pushes a string into the memory, and then it pushes the pointer to the start of it on the stack. And then you push 1, that will push it onto the stack. So it works like an assembly with the stack and everything. And then you call native 1, which is basically just a write syscall. So we'll take this, and the 1 is standard out. So you could do 2 for standard error or whatever. As well. And then you push, then it will take the pointer to this, and it will write. It will call write on that. And then the same thing with this. So it does the same thing for this. And then we push 15, and we call native 60. So that takes the top of the stack and then exits with that. Yeah. So 60 is the same syscall number as exit in Linux. That's why I use that. Yeah, and then I can compile this. So in here I have the assembler, which I can run on the file, and it creates this bytecode right here. So here's the strings in there, and then this is the instructions and things like that, which we can then interpret using this And then, yeah, so there's no new lines or anything like that, because I did not implement escape sequences yet. But yeah, so it printed hello world and goodbye world, and if I echo the output code, it exited with 15, which is not right. What? Oh yeah, that is right, because that's what I put. Yeah, so I exited with 15 as the X code. So I can modify this now. Modify this file, and let's say I want to add a space here, so it looks a little nicer. And then exit with 50, right? And write, so yeah, you can do that, and then we can compile it again. So it doesn't create the file on its own yet. Right now it just outputs it, so you have to direct it yourself, but that's okay. Run that, and then try to compile it. And there we go. So it updated. So you can make as many as you want, like currently. But that's all that you can do now. So there's no like expressions or things like that. But yeah, that's what we've got so far. Yeah. The assembly is more extensive though. Like you can write more in that. That is why I'm compiling it to that. In the future, I'll probably compile directly to the bytecode so that we don't have to assemble it as well. But I'm not doing it yet. Code editor looks really nice as well. Jennifer Tommel and then Lua. Yeah. Yeah. I understand. Yeah. I'm not making it like to try to get other people to use it. Really, I'm making it to learn. So that's why I decided to make my own. If I was actually trying to make like a usable product, I would use an existing thing. Okay, and I was looking for something here. Yeah, I wanted to look at all of the native ones. So those are in here. The native function. So what do we have? Okay, so yeah, we have exit. We have these like string compare and stuff, but that I'm going to implement in the language itself, like for the standard library or whatever. Okay. Yeah, but we need like syscalls. Need to be. This is the only way to interact with it essentially. So we have open, write, read, close. Malloc, we don't really need that because we're using our own memory. Yeah, basically. But we could use that if we wanted to. Yes. So I suppose I should probably, let's see. I thought that this would take a little bit longer, but it does seem to be working out. So something I'm going to do though is automatically like write into. Well, actually, I'm going to update it so that it actually writes into a file. So that's probably pretty useful. So let's actually take command line argument. And then RC is less than 2. Well, it's not equal to, but that's what I'm going to export for now. Then we're going to such that let's make a helper function up here. Hello, Stam. How you doing? So we'll print that standard there. Usage, and you should actually probably pass the file, right? And we will output that here. So file, then file name dot Kano. So it's called Kano script because that is the name of the text editor. So new line, file. Let's do it 1. So we need to pass argv1, right? argv0, right? All right. So now if I build it and I run it, yes, we get that. So then we need to actually get the second argument. So equals argv1, and then we need to pass it into 3. Okay. So now we should be able to run it with any file. Yeah. So it looks like that's gonna work then. But then when we output it, we want it to be the first part of it before the dot, and then TASM right at the end. So let's try to do that. See? So we need to basically strip off the dot. So that's gonna be in the generator. So we'll pass the. I want to pass the file name here, the whole file name, or yeah, we'll just pass the file name here. I think that's fine. And then we will want to basically strip off the dot, and then we want to sprint that onto it. Right. So we'll do output. Output equals dot, right? And that's the file name there. So we'll get the output. So that's going to be pretty easy to make, right? So just dot, and we'll take a stir. And then we'll just do wall. Well, third is not equal dot, and it is not equal that. Then we'll just do stir plus plus. I think that's fine to do, hopefully. Assuming it's properly null terminated, that should be fine. And then we can just set stir stir equals that. And we don't actually have to return anything, because we're modifying the file name. So maybe we should copy this right here. I'll create a copy of it. That might be a good idea. Instead of modifying the actual file name. So I think it's like stir copy or something. Or not stir copy, but stir, is that what it is? Stir copy. Yeah, okay. Let's just do output equals so we need to allocate it first. Times stir by not 5. And then we'll pass this output here, but first we need to string the copy. Let's actually get the one. Let's use file name size, right? When you mention syscall, we're not talking about Linux specific syscalls, right? Yeah, no, that is, I mean, basically we're using the C wrappers around them, right? So like fwrite and things like that. So like it's more cross-platform, but just like it uses the specific syscalls of each system. Yeah, and I think it works on macOS. I don't know if it'll work on Linux or on not Linux, on Windows right now, because there's a few issues with that, and you know how Windows is. But it should work on macOS as far as I'm aware. Yeah, so into output we want file name and file name size. Okay. Then we want to pass that, and then we want to string f into that, right? So I think that'll work. This is probably a function as well. It's an and function. But let's see how that looks. Not compile because I messed things up. Yeah, this needs to be the reference. Yes, that's actually not going to work, so I'll need a new one. Actually do that times plus 4 for chasm. Yeah, so we'll do that. We'll actually do plus 5, so let's do plus size of chasm. Okay. That's a little messy. Yeah, this doesn't need to return anything. Actually, and then let me output it. So I'll just print it like that. Cannot type. Alright, so that did work. That worked. So I'll make void. Well, maybe I will just return it, right? Is the code all one file? Right now it is, yeah. I'm gonna, separate it out, but I like to start with one and then see sort of how it's gonna come about, and then I'll, make it more clean over it. I did just start it yesterday though. It's only like 300 lines, so it's not that bad. A lot of times, like, it doesn't really bother me if it's in one file, because I can just search or whatever, jump around, and I'm kind of used to that. But then it bothers a lot of other people, so then I end up changing it. All right, so we're gonna return this. So it will just has them sure. So we'll just copy this in here. Like that. And we return file. Most people love segregated responsibilities of code and more robust structure. 600 or 700 then split. Yeah, that's a good amount. For me, it gets confusing if I have like a lot of separate, like when I'm first starting, I have a lot of separate files, and then I'm trying to figure out sort of how it's gonna basically come together, if that makes any sense. And then it's kind of hard to work around it. And then if I set it up with an improper structure, I kind of just have to live with that or try to refactor it, which can get difficult, right? I don't know if that made any sense, but that's sort of how I feel. So I like to see how it's going to be structured before I actually separate things out. So we'll open output for writing. And then we will write here, or fprint that rather, onto body. Body. Okay. Alright, that's the only place that we're doing that. Okay, and then we also want to, at the end, fair point, yeah. We just want to, I'm just always going to append, at least for now, just an exit with 0 at the end, because that's kind of like standard. Even though it doesn't matter much because C does that, but I want to do it anyway. So push 0. And then native 6. Alright, that's it. So eventually, like, won't do this, because it's kind of inefficient to just have extra stuff there, but yeah. Let's just run it. Kano.kano, and it should generate kano.tags on here. Yeah, and it has two exit codes. Okay. Yeah, so then we can compile it. So now it actually generates the file. I'm not going to call the assembler and stuff like that yet. When I run it, but in the future I will. But yeah, so that's just a lot nicer to have it generated like that. So let me actually do this because I forgot to do that. Let's see. So structure of and like to add some stuff. Okay. Yeah, that was kind of big. Should have done that earlier, but that's okay. Okay, cool. Alright, so that's pretty cool. Coming together, right? I probably should work on escape characters right now. And that shouldn't be too hard, because it's already supported in the assembly. At least like the basic ones. Like not like hex ones or whatever, but you can have new lines and things like that, and it'll look fine. So like if I manually modify it, and then I compile it, it's actually gonna work. Or not. Wait, what? Oh, it did not save. Oh yeah, because I did not modify it properly. I didn't modify the right file. Yeah, if I do it here, whoops, like this. then I do that, it's gonna actually work. Yeah, so like they're supported in there. So all I need to do is update them in the lexing, right? So I can basically just steal the code that I have for the assembler. Right, so I have like the escape. Oh, yeah, valid escape character. So if it's any of those, these are the ones that are supported. So let's look at that. So I'll probably, let's see. I'm not sure if this copy is going to work because the editor doesn't exactly support copy and paste, so it's not great. It did work though. Looks like mostly. A couple of problems. Yeah. Let's see. Why is there all these extra ones? Okay. Yeah, but other than that, it looks actually good. Maybe not. Wait. Let's see. Does it compile? Yeah. Okay. So it did work. Cool. I think this needs to be. There we go. Yeah. So if we don't need the current index though. Why do I do it? Why do I do it like that? Let's just pass a single character. And then we'll switch over the character. Okay. And that should be pretty much fine. Okay. So then we need to call this while we are lexing the string, right? So if we encounter a backslash, then we want to get the next character, and then we're going to set the single character to this, essentially, is how this is going to work. So, in here, it's pretty messy right now. So let's see if view.data equals one of those. Then, what is this? Oh yeah, it needs to be like that. Okay. So if view.data is that, then want to iterate it by one. So what view equals view chocolate. And then we want to use that character. We want to get the string, and that's what we're going to append to here. Yeah. So what was it called again? Put it up here. Valid escape character. If that actually returns the character. So if, well, let's see. Escape equals valid escape character. That's kind of a misleading name because it doesn't return a boolean, but it sounds like it would. Yeah, so I don't know about that. Let's do view.data. So that's going to be the character, so it's n or whatever. So I'm going to have to do this a different way. If we want like more advanced escape characters, but for now this works. And if escape equals that, then we're just going to exit with 1. For now. Okay. So that's just our way of crashing, because we're not reporting errors yet. And then we just want to append the escape character. Let's do v.learn greater than 1. And that. And does that be greater than 1? Yeah. Well, does this have to be greater than 0? Because we're just chopping 1. So it could be, it has to be greater than 1 because we need the closing string as well. So that's why we need to do that. Yes. So we're going to append the escape. And then we can continue. I'll view chop left again though. Okay. Or we could just yeah, let's just do that. Go back and run it. Let's look at chasm. Yeah, that didn't quite work. I just inserted that. Right. That's not good. So actually, I might have to do that a different way. I just wrote that. So really, we want it to be 2 separate characters. So maybe we want to just grab it. We have to keep going, right? So what if we do that? If we do this, and we got data. So we get the backslash, then we chop left, then we do this. We just, if it is a quote, then it's going to end, so that's why we have to handle it separately. But then we can append that. We don't actually have to do that. Just click out again. So this is basically checking if it's a valid escape character. So we don't actually even need to save it. So we can just do if that. Why is there a lot of extra spaces? I don't know. Equals space. Okay. So. Oh shoot. Right there. I accidentally opened it in the good one. Not Kano. You have to look at the pattern. Okay, there we go. So that actually works. Yes. Okay, so now we have basic escape support. That is cool. Yeah, so now we should be able to compile it. And there we go. Alright, so that's pretty cool. Pretty cool. So, what else? We can insert one of these if we want to. This could be return a boolean now. So let me actually make it so it does that. Because I do that. So use valid escape. Return a boolean. Not a bool, a bool. So let's do this. Follow through. And just return one. Return true now. And then for default, just return false. Okay, these are keywords and not types, and it looks kind of creepy. Okay, then we need to update this to actually say is valid escape. Is valid escape, not character. Okay. I'll put it in there again. Comparison constant 32. Yeah, okay. Got to change that. So, valid. We don't need this anymore. Did not save. And I know why. I actually know what the issue is, so I can fix it. Container.chasm. Container.chasm, and there we go. So it's all working. So I'm going to take a quick break, and I will be right back. Yeah, about 3 minutes. Okay, I am back. So, I closed that. I did that yesterday. Okay. So let's see, what do I need to do now? Build it. Run it with volcano. Okay. So that's pretty cool. Yeah, we can do that. We should be able to like if we compile like exit exit 20, exit stuff like that, and that should also compile. Did not. Wait, why? Why did it not? Should. That is a problem. Why does that happen? It's actually print the token, right? Print open array. And let's see what's going on. Should be modified in there. Didn't print anything. Why did not print? Something is not right. Yeah, okay, it's not working. Okay. Oh, it's exiting one. Yeah, that's fine when you don't record it. Okay, so we have an error somewhere. Why is that? Let's actually let's run it in GDB and see what. And then run with pin. Alright, so we'll next, and it's gonna be in the right thing. So let's look there. Let's go and create exit. It's gonna actually take a minute. Okay, program is not being run. Wait, where was it exiting? Well, it was here. Alright, so it was with the string. What happened? Do that. Build it. Run it. Yeah. Alright, maybe I should actually, report the errors properly. But it is with this, so I need something wrong here. Oh, shoot, because I need to do if not a valid state. That's why. Yeah, that makes sense, actually. There we go. Now it actually worked. Okay, so that was kind of stupid. Alright, yeah, so I'm gonna actually go everywhere we're just exiting and properly report the errors. I could make a macro for that, but let's see how it's gonna look. So, so let's just search for exit 1. Right, so if that, then we'll just do invalid token, right? Here, invalid token, and I think we can put the data. We don't really have that though, do we? Yeah, we could get it actually. So if we do that, we do start class token.lock.call. And let's actually let's print the token location as well. So we want %d%. It's actually a zoo. So token.lock.call. Okay, so that should compile. Right? And we need to exit with as well. Okay. Invalid token. And then where else do we exit with one? So I think we do the same thing here, right? If not, invalid escape, so we can do something like that here. Same thing. Ta-ta. Let's do unexpected, expected escape. Okay. And we can just pass the character here. You got data. Okay. Yeah, so I think we can make a macro for this. So we're always gonna append this to it, right? In the air. So we can have like air, right? Air. And we're gonna pass expected escape character. And then we want to pass the actual character. And we'll need to pass first Uncle Pizza follow. Thank you. I apologize if I mispronounced the first part of your name. Okay, we need to pass the token. Or, no, we just have it, so it's always going to be called token. Maybe not. So we need to pass the lock. So we token that lock. So it'll expect a location struct like this. So I think that'll work. Then we can basically just expand this from that. So let's make a macro. Alright, there. Oops. Okay, so we'll do that. There we go. So we need that lock, right? So we do a lock.ray. That call. And then not this part. How do we need that actually? Yeah. Get rid of this part. Error. Then I think we can stir, and then the arguments for the rest of it. So if we put this stir down, I think that'll work. Something like that. We need this though. Yeah, the parsing doesn't exactly work for the lexing, right? The highlight. Because it does not work on multi-line at the moment. Oh yeah, you get the idea. Okay. Have some issues. Like I mentioned. Oh yeah, so I forgot to put all the arcs here. So how do we do that? VA arcs. Just found that Twitch has programming. Yes. It's pretty epic. Pretty epic. VA arcs. We do that. Okay. And we need to actually test it that it works. So let's put an invalid escape, perhaps. And just make sure that that works. Let's put that. And let's modify the internet cannon. So instead of that, let's do P. I don't think that's a valid one, right? Yeah, it is not. So if we run it, valid, okay, unexpected escape character. So I put an extra new line, I think. Yeah, so we don't need to put the new line. But that works as expected, and it prints where it's at. So we'll press the start of the string. So maybe I should print the location, like the current location, right? No, that's fine. We'll just do it like that, because it's in the string, so I think it's good enough. Because I don't have to change a lot of stuff. So we can get rid of that, and it's going to exit on its own. And we can add this here, and we can modify that. So print here, invalid token, sent S, and we don't need any line. And we can put view.data there, and that should be all good. So that should work. So if we put something invalid here, so instead of right, if we have build, right? And build it. It's not working. It has type int. What is wrong here? Oh yeah, we don't want to do that. Shit, we need to do b.data. No, we need to start. Start plus. We just want the column actually. Yeah, I'm trying to think. So invalid token is what? Token type. Where do we want to print it? I want to print the whole token. So yeah, I think we can do start plus token dot lock dot column. Now if we run it, invalid token that. Okay, we need to do -1, I suppose. Yeah, because we do the +1 on that. Okay, it does that, but it doesn't. We don't want to print the whole thing. So we need the size as well. I can do it like that, and then we get the size of it, which is we need this, right? So that is the start, and then the end, so the current point. I'm gonna take this. There we go. This minus the current point minus this. So that's the start. So minus where is if we just do u.data minus that. I think we need to do this part first. Like that. Doesn't like that. Then we want to get forward. Like that. No. So actually I have the word count, so we can just use that. Yeah, that makes sense. No, we can just pass the word here too. Yeah, let's just do that. We still do this because it does not have the null termination. A lot of problems. Yeah, that needs to be cast equivalent because it is a size type. Huh. It seems to be word.data. Okay, actually word is, it's a dynamic string. So let's do that, and now token broke. Okay, perfect. That is what I wanted. Let's make it that. Let's add that to all the other places. So we want print air anywhere that we do exit. Print air. So what is this? So expected closing, right? Expected closing quote. Like that. And we don't need any of that. Okay, print air. Let's see, where else? Exit one. Side count equals 0, then that means this should probably be an assert actually, rather than this, right? Assert tokens count equals 0. Well, yeah. Let's just let's do that for now, because I think that would means that we have an error, right? Problem with that. Problem in the code. Alright, so this is invalid type, right? There. So we don't actually have the location right now. Oh yeah, we do. Beta is 0. Blah. And then I can type that. the found type of that. So want to print the token types of the current type. So that would be type, right? And then open types is data 0.type. So it's actually that's all right. Let's move this onto a new line. And let's do that. Nope, not quite like that. Okay, like that. That's good. Build that. Try closing. Okay, so it doesn't like that. So I will get to that. This one seems to work, so that's good. That's it. Do you have any other ones? Yeah, so this we don't actually have the location anymore. So I'll need to figure that out. So we'll need to just include the location from the token. For now, just gonna make error. Expected type string. And I'll just give it location 0. I think that'll work. Found type %s. That's a new one. And that's not what I wanted to do. So we need the type. So it is node of types. Node value.a.args.data 0.type. Okay. That should compile, right? Except for this other one. I did not. I did not like that. Okay, I don't know why. We'll figure that out. So 1, so yeah, this is like the same thing. Except we did not expect that thing. No, except they expected it. That's what I said. We found that. Okay. I think it's the last one. Yeah. Okay, so yeah, we might have to do it like that. We can do that. That's not gonna affect it. Shake wood. Okay, so what is the issue with that? Expected that before that token. So I feel like with this first one, it's because we did not pass any extra arguments. Let's look at that. Well, actually, what if we do assert false? Does that work without the arguments? No, so you have to pass arguments to it. Okay. Well, alright, let's just see this and see if that works. Okay. Okay. It's kind of stupid, but did not work. But it didn't save, so. Okay, so that fixed that one. So I don't know what the issue is with this. It might be the location actually. So let's include the token when we create the node. Can we do that? Or include the location. So let's see. Each node is gonna have a location. Location lock. Right. And then yeah, so when we create the node, type. Let's set data equals data 0 dot lock. Like that. Do that. Well, let's just. We don't actually use create node anymore, do we? We set that here. Dot lock equals data 0 dot lock. Data 0 dot lock. Okay. Yeah, then we need to update this to have the location. What the fuck? Yeah, no needs a pointer, so that's fine. Does that fix it? No. Not work with this. No, that's not what it is. Huh. We do have no types. That's not what it is. What's the issue? I don't get it. Macros can get kind of confusing. Like all the CPU processor on there, you know? Okay, that's a lot of stuff actually. I want to look at. Oh shoot, I know what happened. Yes. It's because I need to do the do wall thing. Forgot about that. Do wall 0. There we go. And now we have more issues. What is this? Oh shoot. I need this here. Uh-huh. Alright, save that. And still does that. There. Let me go to that. So yeah, these all have some fun. So that worked fine. Still didn't work. Let's try the CPU processor again. And let's look at it again. Expands into quite a few lines. Standard error. Should type int, but found that. Yes, you just get appended. Node lock dot row. Let's see what else. This and what's at the end? Let's see with 1. Wall 0. Yeah, that looks fine to me. FNF standard error. This. So why doesn't that work? The error messages are not very helpful. Why update this to be like this? Is that one now with? No. Okay, let's go back there. Look at the guy. This one works though, right? Or is that one not working? Yeah, this one works fine. Why does this one work? But not the other one. What is it not like? Effective typing, but found that. No types. Dot type, and that's right. Wait. Oh shoot. It's missing a closing. a closing square bracket. Okay, that's what the issue was, so that's cool. Okay, so we have invalid escape character. I fix that. Everything else should work on it, right? Yes. Okay. So that's cool. So now we have better errors and a way to report them. And if we look at in.chasm, it expands just into that, and then we also have just an exit 0. So maybe I should even, when we're writing it, sort of put what we are writing, you know? So print that file. I can even make a macro for it, perhaps. Do I want to do that? Maybe not now. Because we have comments in the assembly, so we can do this. So we could do like, right. And then this is exit. So that's all I would support for now. But see, and then save that. Get out of here, build it, and then run it on that. And if I look at kingdom.chasm, we get right. We don't get exit for this though. It doesn't highlight properly, but we do have bin pilot. So it looks a little better. Yeah, we did not generate that exit with that, so that's why that did not. But we could just, you know, instead of doing this, we could append one to here when we're generating it, you know? Actually, even at the end of the tokens. What if we did that? I don't know that I want to do that, actually. Do it here, you know? Let's do, parse exit. Actually, is it the same? So most of this is the same. We have a different type. Well, no, it's the same type. We have a different value. And then we have the type of that. Yeah, so we could like try to factor it out, like parse native node, right? And we just pass the current token. I do that. So we consume. We could do all that. Just thinking what we have to pass. We need to pass the tokens inside here. Tokens, and then the, so it's always going to be native, so we don't need to worry about that. But then we need the extra type, so tt_int, right? So we can set the type equal to that, and then we can switch over the type, and we can do the args differently. And once we do the natives that have more than one arg, we're going to have to do this differently as well. But for now, we don't have to worry about that. So then, we need to pass the root node as well, actually. I forgot about that. Because that's what we're going to append to, right? So, let's do parse native node. Well, no, we can use DA appending here. So let's do, node equals that. Then we don't have to pass the root. Grab all this stuff and put it into here. So we can do node parse native node. So we need the token array, and then we need the expected type. So token type. So let's do this, and we're going to return the node at the end. Return node, and this we want to expect type, and then we can switch over the type. And right now we have case tt_int, case tt_string, and then default we just want to compare an expected type, and we can print out the type. We need to pass the tokens.data 0.lock and unexpected type, and we can use token types of the type. Okay, yeah, so if we have the incorrect type. Otherwise, we can take this, put it in here, and so this one is int, the other one is the string, right? So var string. Hey Alvez, hello again, how are you doing? Value.string. And then everything else is the same. Oh shoot, but we need the native type, right? So that's just gonna be an integer. Native type. Native value. It's like that's the syscall number essentially. Not exactly, because it's not really a syscall, but you know. So native value. And that should be pretty much it. So we set the node. We can get rid of all of this. We need to pass just native exit in it. And this one should be able to pass native right. And we want string, pp string. Oops. Okay, and I think we can get rid of all of this. Use DA appended. So let's kind of build that. Node from type node. So it doesn't like node pointer. Yeah, because so it's just allocated on the stack, so that's fine. And just return that. Or you know what, we could even just dereference it. Like that. I think that'll work. Well, we actually allocated, so maybe we should do that. Just do that. Okay. Then we're gonna fall through. I think I forgot to break. Yeah, break. Break. Whoops. Oh, also, Alavaz, if you're still here, did you see that I started the Emacs challenge? And I think I put it at too high of a price. You know, for the of the channel points or whatever. But I did start it, so I might have to modify it. Because I think it'd be fun. I did start it. Because that was your idea. You had like VS Code or Emacs at one point. If I recall correctly. 2,000? Nice, nice, nice. Yeah, I think 40,000 was a little too much. I'll probably extend it until it actually is completed. But yes. Very fun. No type no. Okay, so it's still yeah, because it is not okay. Okay, it is a massacre. Well, the last one I did, it was like 15,000 or whatever, and then it was finished in like 3 days. Or whatever it was. Definition of art. Why is that? Okay, yeah, because this needs this as well. Actually, then it's not going to be used. So let's do art equals 0. And then just set it like this. There we go. So now insertion failed. Okay, that's not good. Down here it failed. Oh shoot, because we didn't we pass a pointer to the token so that we can actually modify it. Right. Because then when we consume the token, we're gonna actually modify it. So that is a good idea. Only have 7k left. Dang. Yeah, well, I'll just extend it till it is completed because I want to do that anyway. So it'll be fun to learn Emacs. Like I'm gonna actually learn it, not just phone it in. You know what I'm saying? The definition of that. How much is a pointer? Yes. Okay, so now I have to change all of that. Tokens data. It's data. Data and here as well. Okay, and I think it worked. Yes. Okay. So I was doing this all so that I could just do that, but I forgot. So then at the end of this, we could just do okay. Parse native node. We don't want the tokens though, so actually that's not gonna work. I wanted to try to call that, but now it's not gonna work because we don't have the tokens. So let's just append it to the token. So we just need an integer in the syscall, right? Or the syscall one. So just at the end of the tokens. You know, or I could just update this. That probably makes more sense. Just grab this. And here, see, wait. Okay, exit push 0, native 60. That's all that I want to do for that. Okay, because I just wanted to have the label. Oops. And there we go. So we have the exit label now, and if you look at it in bin, it's better. Okay, pretty cool. So then you sort of know what's being generated, right? And as it gets more complex, it'll make it easier to really assemble. So that'll be pretty cool. So let me commit this. Move into function and add labels to assemble. Not labels, but comments. To assemble. Okay. Yeah, so that's probably gonna be about it, because I have to go pretty soon. So let me just check on things, and then I think we're good to end the stream. So let's go here. So read the code. So with that, so the next stream it's gonna be like expressions, you know. So so like exit 34 plus 35, that kind of thing. Those kind of expressions. I want proper like multiplication, what's it called? Like the order of operations kind of thing, right? I would like that to work properly. So I'm gonna do some research, you know, in between streams, and figure that out, how that's gonna work exactly, because that's not something I have done before. Made a couple languages, but I've not actually done a multiplication precedence properly. Yeah, so I want to do that. That would be pretty fun, I think. And then it's starting to get pretty powerful, because we have that. We can call to those. Then probably we move on to if statements. Then loops, and then probably functions. So that's sort of like the roadmap, right? Yeah, that'll be pretty fun. Will be pretty fun. But we need this before we can actually do the if statements and stuff, because it's quite important that you can do this kind of stuff, you know? Like the equal. So that's gonna be probably about it then for the streams. Let's test it one more time, and then I'm gonna end it. So in the stream, that is. It's not happening. Okay, and let's look at the assembly. So it generated the write, and then the exit. Okay, and then build passing. Kano.tasm with higher Kano.king. Okay. Yeah, so I would say it worked, and the exit code is 34, so very cool. So that's gonna be it. That is gonna be it. So thank you for watching, and I'll see you guys next time. Bye.